Okay, now we're looking at negative exponents, the standard here. I can apply the properties of exponents to rewrite radical expressions and expressions with rational exponents. And so we need to take a look here at what happens when we have a negative exponent. So the negative exponent kind of definition or rule is that it's the reciprocal of a to the n. Now, if you think back to reciprocal and fractions, reciprocal means that we put it kind of in the opposite location. So a to the negative n is going to become 1 over a to the positive n power. And if I have 1 over negative a to the n, it's going to come to the top, or I could write this as a fraction here. And notice that anytime I change the location of my exponent, it does become positive, but it just changes its location within my fraction. So that's the definition of a negative exponent. And so here's how we can use this. We don't want to have negative exponents because it makes it really confusing to us in terms of what it's actually talking about. Because remember that an exponent means how many times something is multiplied by itself. But if we use 3 to the negative second and we try to think about our definition, that is really confusing to us to think about how could I take 3 and multiply it times itself negative 2 times. And so what we can come up with is 1 over 3 to the positive second, and now I can go ahead and simplify that, and I know that that is going to be 1/9. Okay? Similarly, we want to make sure that we're only applying this negative exponent rule to the terms that actually have a negative exponent. So 2 is just a number here sitting in front. It's different than x and it's different than y. I need to consider these things as different pieces. And so when I go ahead and simplify this so that I have no negative exponents, that number 2 is staying right where it is because it does not have a negative exponent. X goes to the bottom and becomes the positive first, or remember, if an exponent is not there, we don't really need it if it's a 1. And then I would have y to the third. And so I have simplified this thing with positive exponents, and I'm only moving again the terms that are needed. So this time I have 8x to the negative second, z to the third over y to the negative fifth. And so again, my 8 here does not have a negative exponent. It is going nowhere. Okay, my x does need to be flipped to the bottom. Now it is a positive. And I'm going kind of in alphabetical order here. So my next term that I would look at is the y. Does it need to be moved? Absolutely it does. It's going to the top. And then I look at my z last, z to the third. It is staying put because its exponent was not negative. And so I have simplified this example so that it has no negative exponents. We can also go ahead and apply these same rules to our product and power rule that we have already learned. So this would be a product rule so that I know that I could take and add my exponents, and I end up with 2 to the negative first. And then at the very end, because I'm still sitting there with a negative exponent, I can go ahead and simplify that at that point and know that I have 1/2. So we're now applying our negative exponent rules with some of our other multiplication rules that we already have. Similarly for this problem, I'm going to go ahead and use the product rule. I'm going to add these exponents, and I notice that I get 7 to the 0 power. Oh, well, we know anything to the 0 power is really 1. Okay, another way to look at this is if I had 7 to the 4th and I moved that negative exponent to the bottom, I now have 7 to the 4th divided by 7 to the 4th. And remember, anything that is divided by itself surely is 1. So another kind of way to verify that that rule works. Now here we have one last example here, maybe not one last example, an example here where we have a bunch of negative exponents happening with some multiplication and we've got multiple terms. So here's what I would recommend that we do before we get too carried away. Simplify like we have, assuming that this is not a negative exponent. So the first thing I would do here is I would rewrite each term receiving that exponent, and I have x squared to the negative second. I have y to the negative second, and I have z to the negative first to the negative second, times, inside my other parenthesis, 2x to the negative first, y cubed, z to the negative second. Okay, at this point, I'm going to keep this as 5 to the negative second. I now have x to the negative fourth, y to the negative second, z squared, times 2x to the negative first, y to the third, z to the negative second. Okay, and before I worry about any of my negatives and flipping stuff around, I'm going to go ahead and combine as much as I can. So I know that this right here is 1 over 5 squared. I have x to the negative fourth, x to the negative first. I have y to the negative second, y to the third. And I have z squared, z to the negative second. And then I still have a times 2 sitting there as well. So if we go ahead and keep simplifying, I've got 1 over 25 times 2. I'm going to go ahead and group my numbers together. I now have times x to the negative fourth plus negative 1. I have y to the negative second plus 3. And I have z to the 2 plus negative 2 power. I'm kind of out of room, so I'm going to come right over here. And when I multiply my fractions, I have 2 over 25. And I have times x to the negative fifth. This is all on top of my fraction currently. And I have y to the first. And I have z to the 0. And so I'm looking at what I can simplify next. I know I don't want to have a negative exponent here, so I'm going to have 2 over 25. I'm moving x to the fifth to the bottom so that it becomes a positive exponent. Y to the first is going to sit there on top. And then my z to the 0 power is just a 1. I don't need that any longer because multiplying times 1 will not change things. And so I took this really ugly problem here to start out with up here, and I've simplified it down considerably. And that'll do it here for negative exponents and practicing those negative exponents within the rules that we already know.